This Risk Map Learning module will discuss the Coordinated Needs Management Strategy, or CNMS. The Coordinated Needs Management Strategy is a relatively new FEMA effort that was developed to assess and document mapping needs across the country. The purpose of this module is to explain the CNMS, CNMS products, training efforts, and general questions regarding the CNMS. CNMS was developed by FEMA pursuant to the National Flood Insurance Program. The NFIP was created by Congress in 1968 to provide access to affordable federally backed flood insurance protection for property owners and to mitigate future flood losses nationwide through sound community-enforced building and zoning ordinances. Flood insurance rate maps, or FERMs, are a regulatory product administered by FEMA pursuant to the NFIP that document flooding conditions along a stream at a specific point in time. These maps were developed for flood insurance purposes to demonstrate whether a structure is in or out of the floodplain and to enable communities to focus efforts to mitigate risk. The purpose of the floodplain is to store floodwaters during a flooding event. Floodplains are a naturally occurring ecosystem and are serving a purpose. The plants and wildlife that are found in a floodplain serve beneficial purposes. Floodplain management is not a changeless process. There are many factors in the watershed that can impact the floodplain. These factors include, but are not limited to, availability of better topographic data such as LIDAR, changing weather patterns, urbanization, improved infrastructure, and deteriorating infrastructure. These variables also impact the accuracy of floodplain mapping over time. For example, as urbanization occurs, more impervious area is added to the watershed, causing increased volumes of stormwater runoff to drain to our rivers, creeks, and streams. Therefore, there is a need to document these changes and to determine whether the engineering analysis considered these impacts. If implemented, this process will promote more accurate FERMs and enable communities to better manage their high-risk areas. CNMS is the tool that FEMA regions use to manage mapping needs during risk map projects. CNMS incorporates geospatial technologies, current FEMA policies, requirements, and procedures to coordinate the management of mapping needs across the country. Floodplain management and mapping needs will change over time due to the changes in the natural and built environment. Therefore, managing floodplains and recording mapping needs is a challenge. The purpose of this database is to document the needs in a watershed. The effective date of a FERM alone does not authenticate whether the engineering analysis documents changing conditions in the watershed that impact flood hazard information. Due to this, FEMA determined that an evaluation must be done to assess the mapping needs across the country and then document the needs in a central database to effectively manage the national program. Project and data tracking requirements combined with the risk map products and improved technology created the need for a new management system, which resulted in CNMS. The CNMS database replaces the mapping needs assessment process and the mapping needs update support system. MNUSS was decommissioned effective December 16, 2010. The valuable data that is contained in MNUSS will be used as a resource for CNMS. The objectives of the Coordinated Needs Management Strategy are: establish CNMS as a long-term, regionally based mapping needs lifecycle management process, provide a mechanism for data-driven planning and study selection processes, establish CNMS as the voice for communities to identify and report mapping needs and information to FEMA, use CNMS to improve programmatic goals for data quality and quantity, and develop CNMS data for use in other risk map analytical analysis. To simplify the CNMS objectives, the intent is to assist with planning, support tracking, report on current mapping processes, and document the validation status of FEMA's floodplain study inventory. CNMS inventory contributes to the identification of risk in two ways: by indicating where the depiction of flood hazards on FERMs has been validated through detailed assessment, and by showing which previously studied or unstudied floodplains inadequately represent flood hazards. In this way, CNMS leads to the improvement of flood hazard data. Pursuant to FEMA guidance, the following are CNMS components. CNMS inventory records are spatial line work representing flooding sources within the map inventory. Lines are the foundation for calculating mileages and percentages used in new, validated, or updated engineering in-view reporting. The CNMS studies polygons and requests, polygons and points, records store information on individual studies and map update issues logged as requests. The study validation checklist of critical and secondary elements is associated with the study records. The validation process documentation is a summary of specific mapping issues identified from a comprehensive technical assessment of an existing flood study. A new, validated, or updated engineering reporting mechanism is also included in the component of CNMS referred to as the CNMS inventory. The polyline features in the CNMS inventory represent the center lines of flooding sources. Floodplain engineering study validation statuses from CNMS study record polygons are imposed on the CNMS inventory line work to allow reporting of in-view descriptive summaries. In-view summary reports include stream miles and stream mile percentages. FEMA will utilize the CNMS inventory as the sole mechanism for reporting in-view metrics. The CNMS data model consists of three major components. The first is the ESRI file geodatabase. In order to consolidate the data reporting process, a CNMS geodatabase has been created to take advantage of state-of-the-art spatial data inventory tools and procedures. By standardizing, centralizing, and storing CNMS data in a geospatial format, FEMA will improve analysis and reporting by maintaining data that are current, readily available, and reliable. This contains all spatial entities defined in the entity relationship diagram with the proper geometry, relationship classes, fields, and domains. The CNMS ESRI file geodatabase contains two feature datasets, the Studies feature dataset and the Inventory dataset. The entity relationship diagram illustrates the entities in the database, their relationship, and domains. The data dictionary defines the type, format, domains, and field definitions of every entity in the database. The CNMS Studies feature dataset uses the Engineering Study Validation Checklist as the basis for data entry. Utilization of the validation checklist is primarily directed toward the evaluation of existing floodplain studies, the results of which are captured as a CNMS study record. The central purpose of the validation checklist and the validation process documentation checklist is to outline a format that must be utilized to document a condition assessment as being a valid or unverified flood study. Any unverified flood study or a CNMS request record will warrant a review for inclusion in the map production planning process. For existing floodplain studies, this review will be triggered when one critical or four or more secondary deficiencies have been identified to mark these areas as having an unverified validation status. For existing floodplain studies, this review will be triggered when one critical or four or more secondary deficiencies have been identified to mark the area as having an unverified validation status. However, if a severe secondary deficiency exists, such as a high number of new or removed bridges and culverts, then secondary deficiencies can be elevated and considered critical. The decision to elevate a secondary deficiency to be considered critical is subjective, and responsibility rests solely with those making decisions on map update investments. Based on the validation checklist, if the validation evaluation identifies no critical elements and less than 4 secondary deficiencies for a stream segment flood study, then engineering analysis is considered validated. A detailed floodplain study is assigned the valid validation status if it has no critical deficiencies and less than 4 secondary deficiencies. A detailed floodplain study is assigned the unverified validation status if it has at least 1 critical deficiency or 4 or more secondary deficiencies. When a CNMS study record is checked out for evaluation, or when a CNMS evaluation is planned or in queue, the validation status is set to unknown. If a detailed evaluation based on the validation checklist does not lead to a definitive determination of the validity, the unknown validation status is applied to the study. If there is a need for revisiting the validation process as a result of a statutory requirement or availability of new data, the validation status for all affected studies would be toggled to unknown. This review process is also triggered 5 years after the initial determination of the validation status when the evaluation is considered outdated. Such studies are queued up for a CNMS evaluation based on current conditions. If a flooding source centerline in an unmapped area is considered for a new study, then a validation status of assessed is assigned to indicate that the stream has been assessed for a new study. The outcome of such consideration may be that resources are allocated in the current or future fiscal year, or that the request for new study has been deferred. This image demonstrates a visual representation of the CNMS inventory for Kentucky. The following are included: Stream Reach ID, Community Identification Number, Water Name, Validation Status, Miles, Source, Date Validated, Fiscal Year Funded, Justification, Study Type, Line Type, and Status. The need to track engineering analysis is due to the changing nature of floodplains. As discussed earlier, there are many factors that contribute to the evolving nature of floodplains, including urbanization and changing weather patterns. Therefore, it is key to determine whether the level of flood risk on the firm is adequate. There are 17 factors to consider when assessing the existing floodplain, including changes in land use, new and/or removed bridges and culverts, gauge data for recent flood events, etc. The CNMS categorization that will be used includes new, valid, and updated engineering. This flow chart summarizes the CNMS life cycle. FEMA's mapped inventory. First, ask whether the floodplain study is valid. If the answer is yes, then the floodplain study should be reassessed every 5 years. If the answer is no, then consider the option of a new or updated floodplain study when funding is available. If there are unmapped requests, these should be assessed to determine whether a new floodplain study should be completed when funding is available. The CNMS inventory is organized into 3 tiers to distinguish the stream miles in the United States. Tier 1 is based on the inventory type, Tier 2 is based on the validation status, and Tier 3 is the status type. Tier 1, inventory type, defines the stream miles based on whether they are modernized, paper inventory, or unmapped. Modernized includes all studied and mapped stream miles that have a firm database. The paper inventory includes all studied and mapped stream miles that do not have a firm database. Unmapped inventory includes all stream miles that do not have a mapped study. As the process continues, inventory type will change from paper and unmapped categories to the modernized inventory. Tier 2 is validation status. This tier identifies whether the engineering analysis supporting a studied stream in the modernized or paper inventory has been classified as valid, unverified, or unknown. The validation status tier is referenced to provide the official in-view percentage statistics through the formula in-view equals total valid stream miles divided by total studied stream miles. For unmapped inventory, the second tier is assessed or unknown. Assessed indicates that the stream miles in question have been investigated by the region for consideration of a possible mapping project. The validation status will fluctuate as the regions assess and manage the documented priorities in CNMS. Validation is defined by FEMA as the confirmation of an adequate level of flood hazard data reflected on a community's firm, given landscape, current historical climate information, and any significant advancement in the engineering methodology that may have occurred since the date of the effective analysis. The results of the needs assessment and validation process will be stored as part of the CNMS. If there are critical or significant change characteristics as a result of the CNMS methodology, these streams will be labeled unverified. Unverified may suggest that there is a change that may impact the delineation of a flood hazard or flood elevation represented on the firm. However, further engineering analysis may be required. The third tier is status type. This tier identifies the action that has been designated for the corresponding stream mileage. Modernized or paper inventory that are classified as unknown will be categorized as one of the following. To be assessed, the region will determine whether to fund a CNMS evaluation, defer because it is low risk or low priority, or convert to a Zone A. Being assessed, the CNMS evaluation was funded and/or is in progress. Deferred, regional assessment defined the project as low risk or low priority. The study is deferred for a maximum of 5 years before reassessment is necessary. Modernized and paper inventory that is defined as unverified will enter the queue for funding to be restudied and will be categorized as either to be studied, stream miles have been prioritized by FEMA region to receive funding and will go through sequencing, being studied, new or revised analysis is funded or is in progress. Modernized and paper inventory that is classified as valid will be categorized as in-view compliant. The stream miles meet the criteria for in-view and will be reassessed no later than 5 years later. Unmapped inventory will be classified as the following. Not being assessed. This category includes all stream miles that FEMA has not investigated and will include the majority of the stream miles that are not in FEMA's mapped Special Flood Hazard Area inventory. As of September 2010, this was 3.1 million miles. Unmapped inventory that is classified as assessed will be categorized as one of the following. To be studied, the stream miles that are prioritized for funding to be mapped as Special Flood Hazard Area during a risk map project. Being studied, new engineering analysis is in process, or deferred. Stream miles were investigated by the region and determined to be low risk or low priority. The validation checklist is as follows. Critical elements include major change in gauge records since effective analysis that includes major floods. Updated and effective peak discharges differ significantly based on confidence limits criteria in FEMA's guidelines and specifications. Model methodology no longer appropriate based on guidelines and specifications. Addition or removal of a major flood control structure. Current channel reconfiguration outside of the effective special flood hazard area. new or removed hydraulic structures such as a bridge or culvert that impact the base flood elevations more than 5, significant channel fill or scour. Secondary elements include use of rural regression equations in urban areas, repetitive losses outside the special flood hazard area, an increase in impervious area in the sub-basin of more than 50%, new or removed hydraulic structures that impact the BFVs more than 1 and less than 5, channel improvements, availability of better topography or bathymetry, changes to vegetation or land use, failure to identify primary frontal dune in coastal areas, significant storms with high water marks, or new regression equations. It is necessary to verify that flooding source has a record of the criteria that were evaluated and the data that was used in the evaluation. Summaries of the background data should be included. Current and accurate records are critical to describe how the criteria were evaluated with the source and location of the data used. The S-Studies line feature class resides in the CNMS inventory feature dataset under the CNMS geodatabase. S-Studies line is a polyline feature class that is meant to fully encompass the physical extent upstream and downstream of a reach that is regulated by the Special Flood Hazard Area under the National Flood Insurance Program. This feature class will inherit the validation statuses from the S-Studies area feature class to aid in-view percentage reporting. The S-Requests area and S-Request Point feature classes reside in the CNMS Studies feature dataset within the CNMS geodatabase. 2 feature classes have been created in order to store these data as best applicable, either in the form of a point or a polygon. Both feature classes contain the exact same table structure for data capture and storage. The S-Requests feature class are designed to store details concerning update requests from a user and the corresponding data reporting fields for each. In order to populate the database with either of these record types, a user needs to determine if the community request is better stored as a point or polygon feature. This will vary depending on the specific request type. Effort should also be made to ensure the database is fully populated, using the comment field to include any additional information that may prove valuable in the future when this request is further analyzed. The specific needs info table includes general information that will be associated via the CNMS ID attribute with every record that is entered into the CNMS database if applicable. The nature of the information stored in the specific needs info table is intended to capture CNMS record background information. The S-Studies area feature class resides in the CNMS Studies feature dataset within the CNMS geodatabase. S-Studies area is a polygon feature class that is meant to fully encompass the physical extent upstream and downstream of a reach that is impacted by the critical or secondary elements documented through the validation checklist. When creating the polygon shape associated with this feature class, it is important to ensure it contains the affected stream reach entirely and only overlaps any other neighboring reach areas if they are impacted. Once created, the required reporting fields identified in the attribute table can then be populated. CNMS should be updated when a needs assessment determines that the flood hazard information does not adequately convey the current flood risk conditions. The following can trigger the need to update CNMS. The discovery process and preliminary issuance of a firm, issuance of a letter of map revision, community input identifying needs, major flood events, repetitive loss recorded as flooding sources, regulatory requirements, and new data. The Region 4 inventory should be assessed on an ongoing basis and reported at a minimum quarterly. The risk map production timeline demonstrates the triggers that can occur during the risk map process. There are 3 trigger points falling into 2 categories on the life cycle diagram. One occurs where 5 years have passed since a portion of inventory was last assessed in the life cycle process. The other is when at least 1 year has passed since allocation of funding for new studies has been determined pursuant to the CNMS process but was deferred. This CNMS life cycle flow diagram outlines an ongoing operational maintenance strategy for CNMS. All inventory types are addressed. Annually, the inventory and map update requests will be assessed to determine where floodplain mapping work should occur. The list of mapping work is then prioritized and either funded for evaluation or deferred until a later date. Ongoing training is important to enable CNMS to be a consistent process among FEMA regions to develop a standardized process for implementing and managing the data. For additional information, please consult the resources shown on the slide. This concludes our CNMS video module.